we're gonna do logs with exponents really simultaneously. It's not like we're gonna do logs some days and exponents some days. We're gonna do logs and exponents on almost all of these days. Logs are used to solve exponents sometimes, and sometimes exponents are used to solve logs. So we have to be able to go back and forth between the two types while not actually changing the problem. So we're going to first talk about how do I write an exponent in a log form, or conversely, a log in an exponent form. So if we started off with an exponent, let's say we started off with b. That's ugly. We start off with b raised to some exponent, let's just call it e, equals x. So b raised to the exponent e equals x. That's going to be equivalent to the log base b. So when I say base b, you should be writing a subscript. A subscript means it's a little bit lower and it's a smaller type or smaller print. So log base b of x will equal e. So the log, the x, and the e are all the same type. It's only the b that's a subscript. It's written a little bit lower and smaller. Later on in this section, we're going to start having exponents here. So we're going to have a subscript, regular script, and superscript. So you really need to be able to tell which one is which. If you were in my class last year, we did a thing I called drop it, cross it. And for a while, if you want to continue to do drop it, cross it, that's fine. You're going to get to the point where you're not actually thinking drop it, cross it. You just understand what it is. But for the time being, let's just go over drop it, cross it really quickly. So log base b of x equals e. Drop it, cross it is just an easy way for you to remember the order that things go in. So keep in mind, what we're doing is converting. We're going from one form to the other form. So if you're starting with log form, if you apply drop it, cross it, you're going to be going to the exponential form. So if you're going to the exponent form, you don't need to be writing log anymore. You're getting rid of the log, writing as an exponent. So the first thing that you would drop is you would drop the b, cross the e, so that's now the exponent, cross the x equals x. So it's just an easy way for you to remember the equivalent expressions. And again, of course, you can go back the other way. So if you started with the exponent form, if you wanted to apply drop it, cross it, you would be going to the log form. So if you're going to the log form, you need to see the log. You drop the b, cross the x, equals the e. Really, what you need to keep in your mind is that the first thing you see stays the first, the third is the second is the third. That's the drop and cross, okay? All right. So, log base 2 of 8 equals what? And we're going to know what that answer is because of the exponent form. So let's go through this. I'm asking you, what is log base 2 of 8? And you're saying, well, I don't know. Let's find out. So question mark. Log base 2 of 8 is what? So if we apply our drop it, cross it, you're going to drop the 2, cross the question mark, cross the 8. So that's going to become 2 to the question mark equals 8. And if you want to use a variable instead of question mark, you can, but there's going to be some variables in here, and it'll make more sense as to why I'm doing this. So what is the correct power that if you raise 2 to that power, you get 8? 3. So using the exponent rules, I know that the answer to that is 3. Sorry. And it's because in order for this to work, I would have to have a 3 right there. Okay? And so for the time being, I really do believe that putting this kind of question mark here is helpful because you're kind of, it's like a wonder. I wonder what this is. So you will not be able to just look at this and know for a very long time. You're going to have to drop and cross or convert to exponential. So if we converted this one to exponential, we're going to say 5 to what power? So 5 to what power is 1 over 25? So if you did really well on last night's exponent homework, you might be able to tell me this. Does anybody think they have an answer? Melena? It is -2. So it's negative. Why is it negative? Because it's on bottom. 5 was on top. But now the answer, the 25, is on bottom. You obtain a denominator with negative exponents, and then you just think about the number. 5 to what power gets you 25, and that's why you're squaring it. Really think about the negatives as a separate thing. Negatives flip it, the 2 squares it. So it is -2. And it's okay that this is going to take a while for the time being. You're going to get a lot better and faster at this. But for now, this is really quite all right. Okay, so when logs were first developed, they only used a base of 10. Or, in other words, they only did 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. So they only had base 10s. So they used to not write a base. So if you do not see a base, like here we don't see a base, you are assuming a base 10 is going to go right here. And for the time being, maybe the next couple of days, I'll write that base of 10, but in a couple of days, I'm probably going to stop writing it because it's just going to be something that you understand is there. So what I'm thinking about is log base 10 of 100 equals what? So it's still drop and cross, but now you're dropping the invisible base of 10. Well, now it's not invisible because I wrote it, but the base of 10 is our drop. Cross the question mark, cross the 100. So 10 to what is 100? It is 2. Okay, our other invisible base is going to be a base E, and we call this natural log, or ln. It's Latin, and in Latin the L comes first and the N comes second. I don't remember how I say it, but natural log or ln. Let's go ahead and write that because I'm probably half the time I say natural log and the other times I do say ln. They're the same thing. When I say natural log, you're writing ln, or if I say ln, you're thinking about natural log, but you're still writing ln. So natural log. What natural log is for the base of E. So there's an understood base E. You could write log base E of X, but that's not properly written. Nobody writes log base E, but that is kind of what you're thinking about as far as what does ln means. ln means I have a log whose base is E. And what a base of E is, if you have a calculator, you could use the E button. It's the second divide. It's 2.7 something. It's very much like pi, where it's a number that does a lot of really cool, important stuff. One of the things that it does that we're going to talk about in here is it calculates your interest that's compounded in a bank. It also is used to estimate population growth, and it's also used in, I think, the lunar cycle somehow, and I'm not sure how on that one. But we're going to use natural log a lot, and we're going to use base E a lot. So just be prepared for that. again, for a while, I may write a little base e, but after a time being, I'm going to drop off writing that base of e. So in my example that I have right here, I have ln e to the 5th. And this e right here, that's the text, or the regular, that's like the x right here. It's the same size. You're not seeing the base here. There's no base written, but we know that there is a base of e right there. So we're saying ln, invisible base e, of e to the 5th equals what? So let's drop it and cross it. If you drop the e, you're going to cross the question mark, then you're going to cross e to the 5th. E to what equals e to the 5th. And what's the only thing that could be if that's going to work out? It must be 5. Because the only way that this question mark can make this expression equivalent is if that question mark is 5. Any questions so far? Okay, let's go on. So example 1 and 2 is just practicing going back and forth from one form to the other. So in example 1, it says express in exponential form. So that's just saying this is an expression in logarithmic form. Tell me that same expression in exponential form. So drop it, cross it is really all that's asking. So you drop the 3, cross the 4 equals cross 81. So 3 to the 4th equals 81. And that's all it's really asking. It's just practicing going back and forth. And then this is a good mental check. Just does 3 to the 4th equal 81? Yeah. I would never ask you to drop and cross something and be like, tell you 3 squared equals 2. I would never do that. I'm not going to tell you to drop and cross and give you a false statement. So if you drop and cross and get a false statement, I would go back and make sure you're dropping and crossing correctly, okay? Sometimes, like on B, though, you're not going to be able to check this. Because this is, remember, a little invisible E right there. So if you drop that E, cross that X equals 5, you don't really know if that's true or false. You just got to trust that you're doing it correctly. Y'all get what I mean, right? This is something you say, yeah, I know that's right, but I don't know that for sure. So just be careful with it. In example 2, now we're going the other way. I'm starting with the exponents, and I want to express it in terms of log. So if I want to express in log, I need to see a log before you drop and cross. So you have a log, then you drop the E, so E is the base, cross the 32 of 32, cross the X equals X. That is not the best answer, though. What's the best answer? ln. ln 32 equals X, or natural log. I probably would not count this all the way correct, even though it kind of is. It's really poorly written. Nobody would ever write it like that. So this is the correct answer here. Okay. All right, in B. In B, what do you notice first of all? It's flipped. You don't have, like in all of these other examples that we've done base raised to exponent equals answer. Up here, we always write base raised to exponent equals answer. So I need this to be the answer, and the answer is 1/9. I would absolutely take the time to rewrite that as 3 to the negative 2 equals 1/9. Because the drop and cross, it has to be in the correct order to drop and cross. And I'm now noticing I left off C, so we can go back. But all right, so I want log. I'm trying to express as a log. I will drop the 3, so that's going to be the base. Log base 3 of 1/9 equals negative 2. Notice I put 1/9 in parentheses. I think that's pretty good practice because It makes it very clear. It's log of what? It's log of 1/9. It's not really absolutely necessary. I just think it makes it more clear. But I'm overly excited about parentheses myself. All right, so why don't y'all do C and D? Or I guess C and C. So one is going to exponents, one is going to logs. All right, so y'all should get 2 to the -3 equals 1/8. This is one of those that you do know that that's true, so that's a good just checking point, because 2 to the 3rd would be regular 8, so the negative makes it 1/. And then the last one is log base 81 cross the 3 equals the 1/4. Okay, let's go on. Example 3, evaluate. Evaluate means I want to know what the answer is. I don't currently know. Tell me what it is. So I'm going to say equals what? Because in order to drop and cross, you really have to have something on the other side of that equation. First of all, when I drop and cross, I have to drop the base first. What's the base? 10. There's an invisible 10 right there. So I'm going to drop that 10. I'm going to cross that question mark. Equals 1/100. So the first thing I notice is 1/. 1/, tells me it's negative. 10 squared is 100. So -2. Okay, on the next one, B, I need to remember that I have an invisible E right there, and I'm going to say equals what? It is 0, because if you drop and cross, e to what power is 1? This is one of those that we talked about yesterday. There's only one thing that will do this, and it's 0. When you raise anything to the 0 power, you get 1. And that's the only power that does that. It's just a special power that when you raise it to the 0 power, you get the answer of 1. So there's no other choice there. So the natural log of 1 is 0? Yeah. Okay, C. Log base 4 of cube root 4 equals what? So drop and cross, so 4 to what power equals cube root 4. Say it again. It is 1/3. What's happening is that you're trying to relate an exponent to a radical. And radicals are exponents. They're just written as radicals. You don't really... Radicals are not a friendly thing. You want to convert radicals to exponents if you're in exponential form. So I'm going to rewrite this as this right here is going to be 4 to the 1/3. And I have, on this side, I still have 4 to the question mark. So in order for those expressions to be equivalent to each other, that question mark must be 1/3. No, the cube root of 4 is not 2 root 2. Square root of 4? Yeah, absolutely. Okay, D is the harder example. So just go with me and we'll get there. So on D, if I drop and cross, of course I have equals what? So 16 to what power equals 1/32? Okay. All right, so when you're thinking about this at first, in the past, all we've had to do is just say, well, what power is it that makes it make sense? again, you're not thinking about 1 over 32. Just think about 32. What about 16 squared? Is that going to get you 32? Is that even close to 32? If you do 16 cubes, 16 to the 4th, 16 to the 5th, I'm really just getting bigger, and that's not the point I'm trying to get to. So what we have to do is take it back. We have to take it back to a base that we can express them both as. 16 and 32 both can be written with a base of 2. And that's the only way that we're going to be able to solve this without the use of our calculator. So we have to express 16 as a base of 2. So 2 to what power is 16? 4. So 2 to the 4th power. And it's at this point that I'm going to stop using a question mark and I'm going to start actually using x, because this is going to turn into an algebra problem. So instead of writing 16, I'm writing 2 to the 4th, but I still have it raised to the x. And in that same way, you want to express 1 over 32, not as 1 over 32. You want to express it as a base of 2. So first, just think about 32. 2 to what power is 32? 2 to the 5. And then because it's 1 over, will be negative 5. We're almost done. One of the properties we talked about yesterday is exponent to exponent. We multiply these two things. So that's 2 to the 4x. I just multiplied 4 times x equals 2 to the negative 5. And then from here, you're just going to set the exponents equal to each other. It's kind of like in this problem. When you got 4 to what is 4 to 1/3, you just said, well, this exponent must be the same as this exponent for them to equal. So you're going to say 4x must equal negative 5 in order for that to be true. So 4x equals negative 5. Divide by 4. X equals negative 5/4. You'll get some more practice with this, but this is going to also help you memorize those exponents more quickly. While I'm talking about exponents, if you are a junior in here and you are taking the tax ELA on Monday, whether you are in class Monday or not, you will be expected to take the timed quiz on Tuesday, because what we're doing Monday in no way, shape, or form helps you with that timed exponent quiz Tuesday. If you go to extended, which I know y'all probably won't, but I'm just saying. If for whatever reason you're not here Monday, you are still taking the timed exponent quiz on Tuesday. Got it? Okay. All right, I can still go on. At this point, you really do probably need your calculator. We're not going to use our calculator a ton today, but I do need to show you a couple of things on your calculator. So, if you're looking at your calculator, the on button, look at the on button, 2 buttons above the on button, you should see LN, the how and why. I can definitely do that. It's just not a quick thing to show. It's a fairly lengthy process, and so I'm not going to show you. I'm just going to expect that you can just take my word for it. So, the change of base formula. If you started off with log base b of x, and if b is not 10, or e, then you can't type this in your calculator without using the change of base formula. So the change of base is log x over log b. And notice I'm not writing in a base. That's because I'm assuming base 10 here. So you're not really going to see that 10. If you needed to type something like this into your calculator, you're just going to type log x over log b on your calculator. Oh, how do I remember this? B is for base. Base goes on bottom. Okay? So just base goes on bottom. All right. Example 4 says, use a calculator and the change of base formula to evaluate. Natural log, that's a mistake. If you say natural log, what are you assuming the base is? E. So for it to say natural log base 8, that makes no sense at all. Log base 8 of 9. Change it to that. It's a typo. That's poorly written. So let's evaluate log base 8 of 9. If you dropped and crossed, it would be 8 to what power is 9? Is that something that you could solve and give me the answer for yourself? No, absolutely not. So we're going to have to do this in a different way. So log base 8 of 9, using our change of base formula. Notice how I say this. I say log base 8. That really enforces it in my head that 8 is the base. Base goes on bottom. So this is the division where base goes on bottom. So log 8 is on bottom. Log 9 is on top. And if we type this in our calculator, everyone type log 9, close parentheses, divided by log 8, close parentheses. You do need to close those parentheses. You need to tell it where it is stopping for that log. You're going to do it all at once, so log 9, close, divided by log 8. So you should get the answer. It does say thousandth, which is 3. So 1.0566 tells that 6 to go up to 7. 1.057. I kind of didn't read this part. Exact is before you put in the calculator. Approximate is the rounded. It says write the answer as exact and approximate. So this is the exact answer. The thing right before you put it in the calculator is the exact. The rounded approximation is the approximate. Y'all did this a lot in geometry. Sometimes they would say, leave your answer in terms of pi. So you wouldn't actually multiply 3.14. You would just say, the circumference is 100 pi. And it's understood it's 100 times pi. So it's very similar. This is the exact. If you type that in, it's the approximate. So on your homework, if it's looking for the exact answer, you should not be touching your calculator at all. And when I pass out your homework tonight, I'll tell you which problems are 100% non-calculator. It is going to be a half calculator, half non, like it was. Okay, now you try it. Evaluate. Use exact answers only. You should kind of go through the process I went with up here. I tried to solve this myself. And when I couldn't, I said, okay, I have to get the calculator to help me out here. So on 1, if I try to solve myself, I'm going to say, what does this equal? I don't know. Let's find out. I'm going to try myself, and the only way I know how to solve is by exponents. So 4 to what power is 16? 2. So 2 is the answer.
So you wouldn't be using that.
Right. If you can solve yourself, you do.
Okay.
It's when you can't that you must use the change of base. So in example 2, if you drop and cross, you're saying 2 to what power is 13? Is that something you're going to be able to solve? No. So this is not something you can do, so we must use the change of base. So log, which number goes on top? 13 over log 2. It's looking for the exact answer. That is the exact answer. As ugly as I know you think that is the answer I am looking for. Okay, on 3, what is the assumed base? E. Do you think you're going to be able to do this one?
No.
Don't be scared of E. Look at here. You see how 4 and 16, those guys are multiples of each other. Like they work together. E and E, those guys are going to work together too. So this is something you're going to be able to solve yourself. So let's say equals what? So drop the E, cross the question, cross the E to the 3. So E to the what equals E to the 3. That must be 3. This is actually in a couple of days going to be a property that we talk about. If you see two of the same thing with a log or a natural log, it doesn't matter. You can just kind of cross that off and your answer is whatever's left over. But we're going to talk about that later. The next one, do you think this is something that you're going to be able to solve yourself? Absolutely. You're not thinking about 3 and 1/9. You're thinking about 3 and 9. Because if you can work with 9, you can work with 1/9. So, do you just want to say it? -2, absolutely. The negative gets you 1 over, the 2 gets you the 9. They are actually a lot of fun if you do like them. Okay, your homework is 1 through 32 would be non-calculator. I know it seems like a lot of homework, but some of it is just drop and cross. It's not actually you doing anything besides writing 4 numbers down. And then the last 3 will be your calculator portion. Okay? Don't complain. It's not as long as